Here we will look at cubic and reciprocal graphs. So you should already know how to draw a straight line graph, a linear graph. Linear graph is in the form y equals mx plus c. So something like y equals 3x plus 1, and that would be a straight line. It's got to remember with our linear graphs, if it's a negative gradient, it's in the other direction. Also learn about quadratic graphs. Quadratic graphs have an x squared in them, so something along the lines of y equals x squared plus 2x minus 1 and produces a curve. Now, if this is negative, the curve is in the opposite direction, upside down. So in this recording, we will be looking at cubic and reciprocal graphs. I'm going to start out with a reciprocal graph. Reciprocal means 1 divided by, so y equals 1 over x, 1 divided by x is a reciprocal graph. You might have like y equals 5 over x, it's because that's 5 times 1 over x, which makes it a reciprocal graph. So let's fill in our table. 1 over 4, 1 over 2, 1 over 1, 1 divided by 0.8, 1 divided by 0.4, 1 divided by 0.2. Okay, let's just plot our graph here, plot our points, plot our coordinates on our graph. 4 and 0.25, 2 and 0.5, 1 and 1, 0.8 and 1.25, 0.4 and 2.5, 0.2 and 5. Now this graph has a really important feature. What if x was 0? What's 1 divided by 0? Can't do that. It's impossible. So what happens is the graph approaches the, let's just join it with a curve. I'm going to join it from this way. It's just going to be easier. It's a curved graph, the reciprocal graph. It approaches the y-axis and the x-axis, but it never touches it because x cannot be 0 and also y cannot be 0. So if we extended our values, this is just going to help you when you're recognising graphs. We would have had here and here. So that's what a reciprocal graph looks like. What about a cubic graph? Well, a cubic graph has an x cubed term in it. So let's put these values in. 2 cubed plus 2 minus 2 is 8. 1 cubed plus 1 minus 2. 0 cubed plus 0 minus 2 minus 1 cubed plus minus 1 minus 2 and then minus 2 cubed plus minus 2 minus 2. Right, so 2, 8, 1, 0, 0, negative 2, minus 1, 4, minus 2, negative 12. Now this is a curve also, and it just produces a like an S shape. It's like a local maximum and a local minimum here. So cubic graphs look like that. Have a look at this next cubic graph, maybe put me on pause and have a go at plotting yourself. So if x is 3, 3 cubed minus 3 times 3 plus 2, 20. 2 cubed minus 3 times 2 plus 2. 1 cubed minus 3 times 1 plus 2. Minus 1 cubed minus 3 times negative 1 plus 2. Minus 2 cubed minus 3 times negative 2 plus 2. Zero. And minus 3 cubed minus 3 times negative 3 plus 2. So minus 3 and minus 16. Can't quite fit that on my graph. Right, there we go. Got a little bit more space there. So minus 3 minus 16. Minus 2, 0. Minus 1, 4. 0, 2. 1, 0. 2, 4, and 3, 20. And we'll finish off with the reciprocal graph. Maybe have a go at this yourself and put me on pause and pause when you're done. So let's fill in the table first. Y equals 6 over x. 6 divided by 6 is 1. 6 divided by 5, 1.2. 6 divided by 4, 1.5. 6 divided by 3, 2. 6 divided by 2, 3. 6 divided by 1.5, 4. 6 divided by 1 is 6. And 6 divided by half is 12. Okay, let's plot the points. So 6, 1, 5, 1.2, 4, 1.5, 3, 2, 2, 3. Just mark our x-axis. 1, 6, and 0 0.5, 12. So if you can remember from the previous example, it approaches your x and y axis but never touches. These are what we call asymptotes.